Hope the screen is visible. Starting with ISS paper 1 2022, I'm going to start with question number 5. I have already chosen few sums arbitrarily, so I'm going to deal with those sums today only. Okay, so let us address with this sum. Question number 5. It says that x have a Poisson random variable with probability of x equals to 1 is equals to probability x equals to 2. Then we need to find variance of x. So what we know that x has a Poisson distribution, but we don't know what the value of lambda is. And what we also don't know is since we don't know lambda, so if we can actually find out the value of lambda, then we will be able to find out the variance easily. So underlying theory. So let me write question number 5, paper 1. Okay. So the underlying theory says that if x follows Poisson with parameter lambda, that implies expectation of x is equals to variance of x is equals to lambda. And here we have probability x equals to 1 is equals to probability x equals to 2. Let me cross check again. Yes, x equals to 1, x equals to 2, and we are asked to find variance of x is equals to how much. So we know variance of x is equals to lambda. So it will be easy that if we can find the lambda, then it will be easier for us to find the answer of this question. So it is basically e to the power minus lambda, lambda to the power 1 by 1 factorial equals to e to the power minus lambda, lambda square by 2 factorial. So it's going to give me, since this e to the power minus lambda is positive, so we can cancel out from both sides. So it's going to give me lambda equals to lambda square by 2. So 2 lambda is equals to lambda square. Again, we also assume that this parameter lambda is greater than 0 for any Poisson distribution. So we can cancel one lambda. So basically lambda is equals to 2. So this variance of x is actually equals to 2. So this is my answer, that variance of x is equals to 2. So let us check with the options. Yes, so option C is the correct option. Okay, so we are done with question number 5 of paper 1. Let's do question number 6. What it says that x has a binomial distribution with n 3 and p 1 by 3. So x follows binomial with n p. So here it is x follows binomial of 3 comma 1 by 3. So this is the case, and we need to find the value of expectation of x minus 1 whole cube. So let's start finding this thing. Let me give the number. This is question number 6, paper 1. Okay. This is question number 6, paper 1. Okay. So it's given x follows binomial n equals to 3, p equals to 1 by 3. So we need to find expectation of x minus 1 whole cube. Okay. So let us break this x minus 1 whole cube. So x minus 1 whole cube stands for x cube minus 3x square into 1 plus 3x into 1 square minus 1 cube. That is x cube minus 3x square plus 3x minus 1. So we individually can find out the value of x cube, x square and 3x and can deal with this thing. Or alternatively, what we can do, we can find out this x minus 1 whole cube value directly. But what will be the difficulty of finding this x minus 1 whole cube value? That is like whenever we are going to do this n factorial by x factorial and n minus x whole factorial, this x is going to break up into x minus 1 into x minus 2 factorial. So only one x minus 1 will get cancelled out with this, and then rest of 2x minus 1 whole square will remain. So we cannot use this particular formula. So it's better to use this one. My choice will be using this one. So how we can obtain this x cube? You will say that for obtaining x square, that is for obtaining variance, we have we have done too much of we have actually used too much of labor. We have actually done this thing, x into x minus 1. This actually has given me expectation of x square, because whenever I am going to write from this line, I am continuing. Whenever I am going to write this expectation of x minus 1 whole cube, that is going to give me expectation of x cube minus 3 expectation of x square plus 3 expectation of x minus 1. So we actually know this expectation of x, and if you can't remember expectation of x square, and obviously expectation of x cube, it's difficult to remember. So what we can go for, we can go for the MGF technique. For MGF, mxt is q plus p into e to the power t whole to the power n. This is the MGF of a binomial when x follows binomial NP distribution. So if I am going to do the derivative of this thing one time, then it is going to give me n into q plus p e to the power t to the power n minus 1 into p into e to the power t. So that is going to give me np e to the power t into q plus p e to the power t to the power n minus 1. So obviously we know this ddt of mxt at t equals to 0 gives me np, which is nothing but expectation of x. Now further what we are going to do, we are going to do the double derivative. D square dt square of mxt is equals to, we need to do the derivative of this thing with respect to t. With respect to t, this is actually a constant, will remain outside. First, we are going to do the derivative of e to the power t, then the other portion will be remain as it is. Done. Then we will be doing a derivative of we will keep this portion as it is, and we will be doing a derivative of this n minus 1 into q plus p e to the power t to the power n minus 2 into p into e to the power t. Done. Then what we are going to do? We are going to do d square dt square mxt at t equals to 0. If we put t equals to 0, we will be having np t to the power 0 is 1 into t to the power 0 will give me 1, and q plus p is also going to give me 1. So this is basically 1. And this is n minus 1, this is 1, this is also 1, this is going to be p. So this is the value. So this is my expectation of x square, and one more derivative is going to give me expectation of x cube. That is d square dt cube of mxt is equals to derivative of particular thing, that is np. I write it once, then I should do it. ddt of to the power t q plus p into e to the power t to the power n minus 1 plus this thing n minus 1 p to the power t n minus 1 p e to the power t q plus p e to the power t to the power n minus 2 e to the power of t. This thing. Okay. So we are going to do a derivative of this particular big thing. So let us proceed part by part. first NP will be out of the derivative portion. We can do the derivative of this thing. That is going to give me e to the power t q plus p e to the power t whole to the power n minus 1 plus e to the power t will be same n minus 1 q plus p e to the power t whole to the power n minus 2 into p into e to the power t. That is the first portion. Next, what we have this thing. We have n minus 1 into p, and next we have e to the power 2t to the power t whole square, that is going to give me e to the power 2t. So we are going to write 2 into e to the power uh basically 2t, it will remain same, and q plus p into e to the power t whole to the power n minus 2, this thing, plus e to the power 2t into n minus 2 into q plus p into e to the power t whole to the power n minus 3 into p into e to the power t. And this whole thing comes with the NP outside. Let's see. Now we put t equals to 0. Now at t equals to 0, I am writing like this. We will have the value NP e to the power t is going to give me 1. This is going to also give me 1. So this is 1 plus e to the power t 1. This is n minus 1. This is also 1. This is p plus n minus 1 into p. This is 2. E to the power 0 is 1. This is also 1 plus n minus 2 into this is 1, this is 1, and this is going to give me p. So let us simplify this thing. So this is np into 1 plus np minus p plus 2 into n minus 1 into p plus n minus 1 into n minus 2 into p square. So let us put the value of n and p. N is 3, p is 1 by 3. And then 1 plus np is again 1 minus p is 1 by 3 plus 2n minus 1 is giving me 2, p is giving me 1 by 3. N minus 1 is going to give me 2, n minus 2 is going to give me 1, and this is going to give me 1 by 3 and 1 by 3. So this is the final value. So this 1 gets out. So 2 minus 1 by 3 plus 4 by 3 plus 2 by 9. And this finally gives me 2 minus 3 by 9 plus 12 by 9 plus 2 by 9. Eighteen by 9. So ultimately we have 18 plus 12 plus 2 minus 3 by 9. That is actually giving me a value 18 plus 12 is 29 by 9. And similarly, this is actually giving me, let me write it in another color, NP is 1. So 1 plus n minus 1 is 2 by 3. This is 5 by 3. And this is 1. So let us put the values over here. So the values is going to be, this is 29 by 9 minus 3 into this expectation of x square is 5 by 3 plus 3 into 1 minus 3. That is 29 by 9 minus 5 plus 3 minus 3. So that is 29 by 9 minus 5. going to give me, so you need to just calculate it. I am not calculating, so you will get something. Okay, so I need to recheck this value, so please recheck with this portion once, because I have not put the values correctly or not, I am not sure. Please recheck with putting the values and the derivatives, and then you will get the values. So I am not proceeding with the calculations right now, I am just keeping it like it. Okay, so putting it a recheck. Okay, next going for another question. Okay, let's go for question number 14, paper 1. Okay, so it gives n4 summation x square summation y square. So let me write x equals to 4 summation x square summation y square. So let me check the values. X square is 164, 572, 164, 572. And then we have summation x, summation y, 24 and 44, summation x, summation y, and then ultimately we have summation xy 300. So they are asking a question that what is the estimated value of x when y is 10? So y is 10, we need to find x is what? So basically we need to find y as a function of x is the usual thing, but we need to find x as a function of y. Okay, so we need to find x as a function of y, or we can do the reverse thing. We can go for y as a function of x as well, and then we can go for the reverse thing. Okay, so let us write down the function. So first we need to find the covariance. Okay, the covariance means the formula will be, the covariance formula will be, so covariance of xy will be summation xy minus summation x summation y by summation x square minus summation x whole square summation y square minus summation y whole square. In this way, we are going to get the value of the covariance. This is going to give me the value of the covariance. Okay. So that is basically we are, and this is the value of the variance of x. This is the value of variance of y. So we need to do this. This is not the covariance, rather I am writing something wrong. This is correlation. Correlation of xy. This is correlation of xy which I am getting. This particular thing is giving covariance variance, and this is actually giving covariance of xy. Okay. So done, all the values are given, so we can find it out, no problem. So after finding out this particular values, what we are going to do, we are going to write the equation. What is the equation? The equation is y minus y bar is equals to byx into x minus x bar. So we can find y bar, it's pretty easy. Y bar will be summation y by n, x bar will be summation x by n. Okay, so we can find out. So what we need to find out, let's make a list of that. X bar, summation x by n, y bar, summation y by n. These are means. Next, what we have to find out? We have to find out variance of x, which is 1 by n summation x square minus x bar square, and variance of y 1 by n summation y square minus y bar square. These are variances. Okay, and that is can give you the SD of x and SD of y. Okay, next we are going for the covariance xy, which is 1 by n summation xy minus x bar into y bar. Okay, so this is covariance, and ultimately correlation xy is going to be given by covariance xy by variance of x into variance of y squared. So let me write this thing over here like this. I'm going to switch this thing off. So let me write it properly. Okay, and what is this byx? Byx is r. Uh, I should use the notation r into sy by sx. This is that this particular notation. So here, if I have a particular value, I need to find x when my y is 10, and this is actually known. I need to find this out, find this, and this is actually also known. So when after finding this particular thing, that is finding the variance and all other things, and r obviously, I will be able to find the value of y when I will be able to find the value of x when a particular y is given. So in that case, this particular x is needs to be find out. This has a question mark over here where y is 10. Okay, I hope the explanation is clear. So let us compute these things quickly, and we can write these things. So let's make a chart over here. X bar, Y bar. Okay, the value of X bar is 24 by 4. So I am Y is 44 by 4 is 11, and when we have variance of x, variance of x is summation xi square by n, that is 164 by 4 minus 6 square. 164 by 4 minus 6 into 6, that is going to give me 5. So that implies st is going to give me root 5 is dx, and variance of y is 572 by 4. 572 by 4 minus 11 into 11. That is going to give me 22. Implies is dy is equals to square root of 22. Next we go for covariance xy. That is going to give me 300 by 4. Is 300 divided by 4 minus 11 into 6. That is going to give me 9. So R is basically 9 by 5 into 22 square. So that is basically 9 divided by square root of 5 into 22. So that is giving me 0.85. So I will have this byx. I can do it in a reverse way, or I can find it bxy as well. So byx into r into sy by sx. So that is r into that is sy means square root of 22 by this thing. So square root of 22 divided by square root of 5. So that is going to give me 1.8. So what I have to write, y means 10 minus y bar is given as 11. 10 minus 11 is equals to 1.8 into x minus x bar is 6. So minus 1 is equals to 1.8x minus 6 into 1.8. So 1.8x is equals to 6 into 1.8 minus 1. So that implies x equals to 6 into 1.8 minus 1 divided by 1.8. So that's give me approx 5 points. So let's check out the answer. It's 5.44 something. So 5.4, it's close to this value, 5 point something. So what we can do, we can try this out in a reverse manner as well. Let me take another pen. We can find out bxy r into sy by sx. That is going to give me, let me check with bxy. Bxy is going to give me 0.85 into square root of 5 divided by square root of 22. That is going to give me 0.40. 0.40. Then the equation will be x minus, just a minute. Then the equation will be x minus x bar is equals to bxy into y minus y bar. So x we need to find, x bar is 6. This is 0.4 into 10 minus 11. So it is going to be x equals to 10 minus 11 is minus 0.4. So basically minus 0.4 plus 6. So it's going to give me 6 minus 0.4. So it's 5.6 approx. So it's basically 5.49 or something like that came. So we can approximate it to 5.5 as well. So basically this option is the correct option. Okay, so we can do it in both ways. The next, going for the paper 2, where I have selected also few sums. Okay, so this is a very easy sum. Not sum, basically it's theory. So we are considering two-way classification with our observation parcel. So this is a model for ANOVA. All of us know that. So I runs from 1 to P, J runs from 1 to Q, and K runs from 1 to R. So we are considering the sources, that is factor due to alpha, factor due to beta, factor due to interaction, factor due to error, and the total degrees of freedom is PQR minus 1. This is my total DF. Okay, so it's done. Now they are asking for the DF of alpha. We know the DF of alpha is P minus 1. The DF of beta is Q minus 1. And what will be the DF of this error and what will be the DF of this interaction? Okay, so P minus 1, Q minus 1. So they are saying that T, U, V, W, R respectively. So as they are saying T, U, V, W, R respectively, so we can discard this option B and option C easily, which starts from Q minus 1 and R minus 1. Then after that it comes U, which is this. So we can go for option A because it starts with R minus 1. So we can discard D. But what is the value of this thing? This is, we actually know this is P minus 1 into Q minus 1, and this particular thing is PQ into R minus 1. So let me write this in a particular table. So since there the pen tab is not working properly, so it's two-way ANOVA with R observation per cell. That actually gives me the sources and its corresponding DF. If the source is alpha, it's due to alpha basically. Then it is P minus 1 as I runs from 1 to P. Then if it is due to beta, then it is Q minus 1. J runs from 1 to Q. If it is due to interaction, then it is P minus 1 into Q minus 1, where this K I can say runs from 1 to R. And if it is due to error, then it is PQ into R minus 1, and the total is PQR minus. Okay, so these are the degrees of freedom. So they have actually asked for they have started from this TUVW. So they have asked for TUVW. This is TUVW, and this was actually given. Okay, so in that case, we have checked the order, and as per the order, this was the correct answer. Okay, so next, going for another sum. Let's check some small sums since we are running out of time. Okay, let's check with this one. This is question number 15. It says that x1, x2, xn is a IID sample from binomial n comma p. So the sample size is basically m, and the parameter of the binomial distribution is n and p. So CR from a lower bound for the variance of an unbiased estimator p by 1 plus p. So that is my xi p over here. So p by 1 plus p. So let us write this thing. So what we actually have x1, x2, xm. So this is m IID sample from where? From binomial n comma p. My xi p is p by 1 plus p. Let me cross check it once. Yes, it's p by 1 plus p. So we need to find the CRLB. So the question stands is CRLB is what? This is my question. So let's start finding out the CRLB. So what is the formula for CRLB? We need to find the joint distribution of this set of data x1, x2, xn. So we are going to find the joint distribution of this x1, x2, xn. So let us find the joint distribution of this x1, x2, xn. F of x curl equals to, we will have ncx1, mcx1, mcx2, and so on, mcxm. Sorry, just let me write in a proper manner. Binomial parameter is n, so ncx1, ncx2, and ncxm into p to the power x1, p to the power x2, p to the power xm, and q to the power n minus x1, q to the power n minus x2, and like this we will have q to the power n minus xm. So how we can combine these things, since they are IID, so we can write it as a product. So we will write product over I running from 1 to m ncxi. This is one thing. Next, what we will have, p to the power summation xi, I running from 1 to m, and we will have q to the power nm minus summation xi, I running from 1 to n. That is basically, this term I can write as q to the power m times n minus xi product of this. So that is going to give me nm minus summation over xi. Okay, so this is my joint distribution. Now what am I going to do? I am going to do a single derivative of this particular. Now I am going to take the log of this particular distribution. So let me take the log. Ln of f of x curl is going to give me log of this product of ncxi log ABC is going to give me log A plus log B plus log C plus summation over xi into log P plus nm minus summation xi into log Q. Or Q means 1 minus P, so we have Q. Okay, next we will do a derivative of this with a single derivative with respect to P. So with respect to P, this is going to give me 0. This is going to give me summation xi by P. This is nm minus summation xi. So in this line, I am now changing Q as 1 minus P. So it is 1 minus P into minus 1. Okay, so this is my derivative, which actually is summation xi by P minus nm minus summation xi by 1 minus P. Now we are going to do a second order derivative of the same function. So it is log of this thing. So that is going to give me summation xi minus 1 by P square minus it is going to give me nm minus summation xi into minus 1 minus p to the power minus 2 into again minus 1. So I hope that I have done the derivative correctly. Please cross check once. So that summation xi by p square minus nm minus summation xi p. So the expectation of minus particular function that is going to give me summation xi by p square plus nm expectation of basically nm minus summation xi by 1 minus p whole square. So this expectation can go inside without any problem due to the IID property and also the sum law of expectation. So this is summation of expectation of xi by p square plus nm minus summation of expectation of xi by 1 minus p whole square. So that actually gives me this summation runs from 1 to m. So this is m and expectation of xi is np since the binomial is np and this is p square plus nm minus this is also mnp by 1 minus p whole square. So that actually gives me nm by p plus nm into 1 minus p by 1 minus p whole square. So 1 gets cancelled out. So we are left with this nm by p by 1 minus p. So this is the IP, what we called IP for CRLB. Now, phi p is p by 1 plus p, which we can write as p into 1 plus p to the power minus 1. Now, we need to do a derivative of this thing. Phi prime p is going to give me 1 plus p to the power minus 1 plus p into minus 1, 1 plus p to the power minus 2. That is also 1 by 1 plus p plus, sorry, not plus, it's basically minus p by 1 plus p whole square. So that we can write a little bit in an innovative way, minus p by 1 plus p whole square. So that cancels out and that left with 1 by 1 plus p whole square. So basically CRLB is 5 prime p by I theta. So 5 prime p whole square. So basically we are having this. So ultimately we can find this. So we have both the values. So 1 by 1 plus p whole square by this CRLB value. I think we can simplify this a little bit more. We can actually take nm common and then we can write 1 by p plus 1 by 1 minus p. That is going to give me nm by p into 1 minus p. So 1 minus p plus p is going to give me nm by p into 1 minus p. So this is nm by p into 1 minus p. So hence we can figure out the value from over here. So let's check this out. This is 1 by 1 plus p to the power 4 into p into 1 minus p by n. So let me write it as pq by 1 plus p to the power 4 into nm. So let's check the options. pq by 1 plus p to the power 4 into nm. So this is the correct option. Is it clear? I hope it's clear. So let me go and check for another small sum. We have only 5 minutes in hand. Okay, so let's go for this question number 54. So it's giving me a pair of data. Four pairs are there. Powerful function, uniformly most powerful test. Size of the test, larger of the two types of error. Neyman Pearson, maximum power of fixed level of type 1 error. And randomized test not based on the sample observation. So, how many pairs are not correctly matched? So, we need to check. So, basically, size of the test, uh, we can't say like this larger of the type of errors. We can't say larger of the type of errors. It is basically type 1 error. So, it is not matching. Power function is uniformly most powerful test. It's not like that. So, randomized test is matching. So, we can say at least only two pairs are not matching. So this was something a very small one. Yeah, we can go for this sum. This 55. This x1 x2 xn is a random sample of size n from normal mu sigma square, where mu is unknown. Then the most efficient biased estimator of mu. So if you can see that if we are going for the efficiency of the estimator, so we know x bar is unbiased, and if we can go for this particular thing, so this can be written as 1 plus 1 by n into x bar, just an intuitive checking. So if n tends to infinity, this will tends to 0, and this is again as usual as x bar. So the most efficient bias, so these two are basically the biased estimators. So which one is most efficient? For that's why you need to go for the efficiency checking. So for efficiency checking, you need to find the variance of these two estimators, whose one, because the efficiency measure says that efficiency is 1 by variance. So whose variance is going to be larger, that variance, that efficiency is basically less. So in that case, we were going to check the variances of these two estimators, and then we can proceed further. I hope it's clear. Is there any doubt from anyone? Hmm, guess not.